Hi, everybody. So, in this last section of Chapter 5, we're going to put our logs to use and help them make predictions on things that have exponential models. So, and because we're going to see this, eventually a lot of these questions boil down to solving an exponential equation when your unknown is an exponent. So, that's where the logs come in. So this first one's going to be a money related problem. It has to do with compound interest or exponential growth of money. Suppose you invest $8,000 in the stock market, and it grows. That investment grows at an annual rate of 6%. Okay. The question is, when is its value 10,000? When and how long does it take before the value is doubled or tripled? Okay. So let's review the equation for this. If you amount, because we know that increasing something by 6% is the same thing as multiplying it by 1.06. Okay, so increasing 8,000 by 6% is this, and then after t years. So this would be the value after t years. So let's call this A. So let A be the amount after t, the value of your investment after t years. So if we want this to be 10,000, we just replace A with 10,000. And now we go about solving this exponential equation for t. First, we want to get rid of this 8,000. So we'll divide both sides by 8,000. Okay. This is 10/8, which reduces to 5/4, which reduces to 1.25, or 1.25. Okay, and this is 1.06 to the t. Now we just go ahead and take the log of both sides if we want. We could actually say, we could actually write this as t as the log base 1.06 of 1.25. Let's just take the common log of both sides. To the t, we can bring the t out front. Okay. And then divide by the log of 1.06. And we use our calculator to find this, and this is 3.83 approximately. So it would be 3.83 years for it to reach 10,000. Okay. Now, as for the second part, how long would it take to double? Well, doubling it would be 20,000. So okay, sorry, 16,000. Sorry, I was thinking about this. Our initial investment was 8,000, so the doubling it would be 16. And if we once again divide by 8,000, we get 16,000 divided by 8,000. That's 2. Okay, and notice that for this particular problem, we don't even need the value of the initial investment. Okay, if we just want to know how long would it take to double, if you're growing at 6%, whether you invest $1 or $1 million, you'd use this equation. So again, we can do the same thing we did before by taking the log of both sides, and you'll see that t is going to be the log of 2 divided by the log of 1.06. Okay, and this turns out to be approximately 11.90 years. So this is for part A. This is for part B. And then finally, if you want to know how long it would take to triple, well, you could set this up again the same way. You know, it would be 3 times 8,000 equals 8,000, 1.06 to the t. Divide by 8,000 again, and you'll get 3 equals 1.06 to the t. And do the same process again, taking the log of both sides, bring the t out in front, and you'll get that this is going to be, t will be the log of 3 divided by the log of 1.06, which is approximately 18.85 years. Okay. Now, just in case you were wondering, how long does it take to quadruple? That is, when does the investment grow to 4 times? That turns out to be, you can check, this is 23.7 years. And to quintuple, that is 27.62 years. Okay. All right. So why do I bring that up? Well, let's say if you put $8,000 in, you invest $8,000 at the beginning of your career. Okay, when you start saving for retirement, that $8,000 now is grown to, in less than 30 years, that $8,000 has grown to $40,000. Okay, so that's the power of compound interest. And in fact, of course, you're going to be, hopefully you'll be putting a lot more than $8,000 in the stock market, right? The strategy is to invest a little bit each month or each year. So just think about how fast that will grow, assuming the growth is 6%. So that's you want to start saving for retirement as soon as you can, and have a long range view. So we will continue with some more examples in the next video.